Ever install one application to have it break another application? Join us to learn how sandbox applications can prevent that.
You're watching IT Pro TV.
Hello, ladies and gentlemen. Thank you for tuning in to more of the CompTIA Linux Plus show. This episode, we're going to talk about supporting sandbox applications, and here for some of the specifics is Don Pizzette. Don, what can some of our viewers expect to take away from the episode?
Well, we're going to run through what sandbox applications are, because that definition has become a bit of a moving target over recent years. And then we're going to look at two of the big leaders in the area, which are snaps and Flatpaks, and we'll see how we can leverage those inside of a Linux operating system.
So with sandbox applications, I know we have the CH root. Is this going to be the same thing as like let's say an application that's been CH rooted?
No, it's actually quite a bit different now. It's strange because it used to be that when we talked about a sandbox application, we were talking about an application that was isolated from the operating system, that we didn't want the OS to be exposed to an application. If you think about like a web browser, when you're browsing the internet, if an attacker somehow manages to do a drive-by attack and compromise your browser, they then have access to the underlying operating system. So sandbox applications were originally developed to help prevent that. That if somebody broke into the application, they couldn't get outside of it. Now, Wes, you mentioned CH root. Let me bring up a diagram. If you're not familiar with CH roots, it stands for change root. That you could run an application and you could change its root folder so that it was unable to see the rest of the file system. And they called that creating a CH root jail. You were kind of putting the application in a jail. If my web browser ran and I changed its root to be a subfolder of my home directory, then that's all the web browser would see. If I wanted to save documents that I downloaded from the web, they'd be saved in that jail. The web browser would be unable to see the whole rest of the operating system. Now, that sounds great, right? It's a great way to isolate an application, but it brought along with it a lot of problems. So there's the main problem you bump into is that your applications couldn't talk to each other. If I had a jailed web browser and I wanted to save a file to another jailed application like a media server or something, they couldn't talk to each other. They were jailed, they were separate. And so it put a lot of extra effort into it for regular people, and so regular people didn't use it. In fact, largely only used on servers. And even then, it's multi-tenant servers. If you have more than one user sharing the same server, then we might need to divide it up so the users don't bump into each other. That's where we see those things leveraged. That's largely been replaced by containers these days. When you bring up a Docker container, for example, it's like a CH root jail. It only sees the file system you allow it to see. The difference being that Docker containers can easily share volumes between each other, and we can kind of spin them up as we need them and close them out. So they give us a little more flexibility. They also isolate memory and processes, whereas CH root jails were really focused on the file system alone. So containers are a better way to do this, and that's where most of that workload has been moved off to, right? But in this episode, we're talking about snaps and Flatpaks, which I've totally not mentioned here. Well, the reason is these types of isolations were designed to protect application or protect the operating system from applications. Our newer style sandbox applications are flipped around. Well, we're actually protecting the application, not protecting the operating system. You know, when you install an application, like when I drop to a terminal and I start to install things, applications tend to come with dependencies. If I do like a sudo apt install MC, for example, so Midnight Commander. Midnight Commander is bringing along libssh, arj, these are recommended libraries, but all these extra libraries that come along with Midnight Commander, all right? So if I install it, it's going to install all of those additional libraries. Well, I might go and install 3 other utilities, and those other utilities might have some of the same dependencies. All right, so now they share these dependencies. Well, when I update that dependency, let's say there's a library and I update it to the newest version, Midnight Commander might be ready for that new version, but my other application might not be, or vice versa, right? See how I just installed libssh version 1.8.0-2. All right, well, Midnight Commander is ready for that. But if my other application isn't, and maybe we upgrade to libssh 1.9, well, now one application breaks while the other still functions. The dependencies cause a problem. So with modern sandboxing, what we do is we take an application and we wrap it up with its dependencies so that Midnight Commander could have libssh 1.8, but another application could have libssh 1.9 or 1.7 or whatever. They maintain their own copies of all the libraries. On a positive, that means they can each be supported at the level they need to be. On a negative, for us as the users, we have more than one version of a library stored on our system, right? So it takes a little more space. And from a security perspective, it's hard to keep our system up to date. I might have updated the library with current bug fixes and security patches for one application, but not the other. And so that's a challenge that we run in with these, and it's a criticism of modern sandboxing, is it's not truly a walled sandbox anymore. It actually can create some challenges. But there's several players in the market that are creating this, and let me just bring up my web browser. One of the big ones is Snap. So Snap is the one that Ubuntu is kind of backing. The snapcraft.io website, you can go to it and browse around and see all the different applications that you can download. And when you download an application from them, it's coming along with all of its dependencies pre-packaged in. Flatpak is another one. This is more on the Red Hat side. Fedora has adopted Flatpak. Same idea though, the application and all of its dependencies bundled together, and you get them all in one, and so the application has the environment that it absolutely expects. And then AppImage is a third one. That's another one that's out there. Same idea, application dependencies bundled together. You download and install them. Multiple applications maintain their own copies of dependencies. So functionally, they're really all about the same, right? And this is an emerging technology, so we still have to wait to see who's going to be the dominant one and the others go away. But for right now, you've got a lot of choice and a lot of selection.
So if all the functionality is the same, Don, which one out of these examples that you've given us is the most popular?
All right, well, so far, Snap is the most popular, and the main reason is it's the one that Canonical chose, so Ubuntu has a huge install base, and Snap is installed by default when you install Ubuntu. I'm running Ubuntu 20.04, but even in the newest one, 22.04, snaps are installed by default and ready to rock. So that makes it have a very large install base. Flatpak is not installed by default in like RHEL, for example. In some versions of Fedora it is. Well, Flatpak running on Fedora, which has a smaller install base, makes it a little bit less popular. But those are kind of the two front runners right now. AppImage, not really making giant headway. Maybe one day it will. But Snap is probably the most popular, and then after that we would have Flatpak. Kind of the way that it's all panned out so far.
So Don, let's say that we've got two applications installed. Let's say one is in Snap and one's one of the native applications. Are they going to behave differently?
You know, as far as how they behave, probably not, right? A lot of times you don't even notice. In fact, here, let me show you so you have an idea of what this is like. So let me just drop here to my terminal, and I'll show you an example. So first off, we need to see if we even have Snap support installed. I'm on PLAB Client 01, which is Ubuntu 20.04. If I do an LSB release -A, you can see my version of Ubuntu. Did a pretty clean install. I just changed the wallpaper, and that's it. So I'm going to run sudo snap list. If you have Snap support installed, this will list any application that's been installed with Snaps. And I can see I've actually got several things. I didn't install these, right? This is part of my default install of Ubuntu, and I can see a number of things that are in there, like Core 20 and Bear. Those are the base requirements for Snap, so it needs those to run. Snapd, that's the Snap daemon itself that's actually handling the management of the app, so that's kind of a critical one. The other ones are not critical. These guys right here, there's the Snap Store, where we can find additional Snap applications to install. GTK Common Themes and GNOME 338. That's actually the GUI for my systems. If I was on a server, I wouldn't have GNOME or GTK installed because I wouldn't have a GUI. But here on my client, I do, and I can see it's actually installed Snaps for those. Now, I'm logged in using GNOME. I'm looking at a GNOME desktop right now. I didn't know it was a Snap until, well, actually, I guess I did know ahead of time, but you might not know until you actually pull up your Snap list like this. So if it's natively installed or if it's installed with a Snap, it's really going to look about the same. And so let's say I want to install something. So I could do a sudo snap install and then the name of the application that I want to install. Now, not every application is available as a Snap. I'll just use a quick example here of Hello World. So there's a Hello World application. And so we'll install that, and you'll see it's reaching out, and it has to pull, notice, Snap Core. I've already got Snap Core. Well, I've got Core 20. This application must be expecting a different core, and that's okay. Snap handles that. It's downloading the other piece. Remember, these are sandbox, so they'll have everything exactly the way that they want it. So it's going to bring that down. It's bringing the application down. Whoops. And let me just do a sudo snap list. And I can see that I now have the Hello World app installed right there. and I've got 2 different versions of Snap Core installed, so the applications will be able to use those as appropriate for it. If I run hello-world, I don't have to tell the system it's a snap. I just run the binary. When you install a snap, it actually gets added to the path so it can find it to be able to run. There's a few changes that happen to your system, and the biggest change you'll notice is when you pull up your block devices. I'm going to do LSBLK, listing my block devices. Now, normally I would just see my hard drives in here. I've got SR0, that would be my CD, DVD drive, and then I've got SDA, that's my first hard drive. But I've got a ton of loop-back storage devices, all these loop 0 through 9. The more snaps you install, the more loops you're going to have. It creates like a virtual mount point for each one. And you'll see they're mounted into /snap/ and then whatever the name of the application is. So for example, that hello world went into /snap/ hello-world, and it created a folder called 29. This is version 29. I could have more than one version of the same application installed, which is useful when you're doing things like Perl or Python or whatever you want to call a very particular version. But if I go into the current folder, which is just alias to whatever is the newest, I can go in there and find bin, and there's the binary. It's using echo, it's using sh, it's using these commands to be able to generate the hello world message and show it up on screen. Now, that's a pretty simple application. More complex applications would have a lot more in here. I might see library files and other things that are in here that come along with the Snap application that I installed. But each of those are being carried along, and they show up as virtual hard drives. And if you do like a df-h to pull up your hard drive utilization, you'll see each one, and look at the sizes. They're really small because they're just the size of the application. In fact, where's my hello world? I'm overlooking here. 128K, really, really tiny, right? Some of the other applications like Core, 58 megabytes, that's just going to be the application size.
What happens, Don, if I have an application installed locally and in a snap?
That can happen, right? So there'd be a conflict in that case, and at least as of right now, most operating systems will default to using the natively installed version of an app, right? So let me give you an example there. I'm going to do a sudo snap install lnav. Lnav is a neat little log navigation utility, so I'm just going to install that real quick. It's going to reach out and pull it, so it's getting it from the stable channel. It'll download, and it'll install it. Once it's done, I'll be able to run it, and I'll know it's running from the snap because that's the only one that I've got installed. But after it's done, I'll go in and install it from the native libraries, or from the native repo, and we'll see it a little bit different. So now that it's installed, I'm just going to run lnav. And so there it goes. It runs. I see my log files. It's all pretty. I can navigate around in it and see it, right? So the utility's working the way that I intend it. I'll just hit Q and quit out. If I do lsblk, I see I now have a loop 10, which is where lnav was installed. And if I go into /snap/lnav, and take a look in there, I can see that version that I just installed. It does have a lib, meta, USR folder. So it's got folders for all the different components that it brought along with it, all right in here. So I am running the snap. And if I run which lnav, it'll tell me that it's running /snap/bin/lnav, right? But now I'll do a sudo apt install lnav. And so now I'm just installing with apt. So this is going to come from the regular Ubuntu repositories. When I run that, it's going to find lnav, and notice it's pulling along some dependencies just like we've seen before, so it's going to grab those, it's going to get them installed. It doesn't recognize the dependencies that were installed with the snap. Those are sandboxed. Those are a part of the snap install, not a part of the base OS. So now it's going to install those here in the base OS, and once it's installed, if I run lnav, I don't really know which one it ran, right? Did it run the snap or did it run the native one? Well, if I do a which lnav, I can see it ran /usr/bin/lnav. It's preferring the native app to the snap. Now I could still run the snap. I would just have to provide the path. If I pointed to /snap/lnav/current/bin, oh, is it not bin? Oh shoot. Well, now I don't know. So whatever the binary is actually called, it's tucked away in there. I'd have to find it. That I would then be able to execute that directly. Oh, it's buried under USR. So we could come in and find it like this and run it, and now we'd be running the snap version right there, right? But I'd have to manually specify. Now, you typically want to avoid that. You don't want an application installed twice if you don't have to. So I would either need to pick get rid of the snap or get rid of the native application. And if you don't really care about the benefits of the snap, then you could just get rid of that by saying sudo, hang on, I got to get out of the folder, sudo snap remove lnav, and that's going to remove the snap version of it, so that's gone. If I do a sudo snap list, I can see lnav is now gone, but I still have my native local version. If I do a which lnav, it's still there. I can still run it.
So with Canonical backing Snap and that being heavily utilized inside of Ubuntu, let's talk about RHEL environments, Don. I've heard about Flatpak, and they seem to prefer that. Can you tell us about Flatpak?
Flatpak is basically the same idea. Same basic idea. It's a different package format, so they're not compatible, right? But it works a slightly different way, and I understand why RHEL prefers it. Whereas Snap will like clutter my screen with all these virtual hard drives, Flatpaks don't do that. Flatpaks have a different mechanism for keeping things isolated, so it's a little cleaner. And RHEL is all about stability, consistency. You know, they want things to be cleaner and simpler. But Flatpak is a very viable choice. You can use it. Actually, you can use it here on Ubuntu. I don't have to go to a RHEL machine. I can install Flatpak. And I can even uninstall Snap. Like if I go and remove all the different Snap library or applications, you snap, sudo snap remove, and then do each one. You have to leave snapd and core. So everything but snapd and core. Then you can just do a sudo apt remove snap or snapd. And then it'll remove that, and now you remove Snap support from your system. So it's easy to remove it.
So Don, with Flatpak, can we use that on Ubuntu, or is that only going to be in the Red Hat environments?
No, you can use it on darn near anything. It's just not installed by default. So like the Flatpak utility is actually part of the Ubuntu repository. You can just install it and go. Now you need to make the choice of whether you want to run it at the same time as Snap. You can run both side by side. There's not a lot of reason for that though, so I encourage you to pick one and stick with it. You know, so for me, it'll usually, well, actually for me, it's usually neither because I'm not a big fan of these. But if you're gonna pick one, just pick whichever one has the applications that you need. So in my case though, I'm gonna leave Snap on my Ubuntu machine and I'm gonna add Flatpak to it. So to do that, we'll just say sudo apt install Flatpak. And you'll see that's gonna come right from the regular Ubuntu repository. Notice that Flatpak, it's P-A-K, it doesn't have a C in the name, and that'll just get installed. And once it's there, I've got Flatpak installed, and unlike Snaps, which kind of mess up my system a little bit, I get virtual hard drives and pre-installed binaries and things. With Flatpak, it's very clean. If I do a sudo Flatpak list, it'll pull up a list of what's installed, and there's nothing. No core, no snapd or whatever like we see with Snaps. Very, very lightweight. That's really what Flatpak's goal is. Now, it's so lightweight that when I install it, it doesn't have a default repository. If I was on a RHEL-based system or like Fedora, Fedora has a default repository. They maintain one of Flatpaks that they use. But for everybody else, we need to use a different repository. We could make our own, or we could leverage a public one. I'm going to use one that's called FlatHub, flathub.org. They're probably the biggest Flatpak repo that's out there. So you can use that, or you could set up your own. But I'll just add that in here. I'm going to say sudo Flatpak remote-add. I'm adding a remote repository. I'm going to call it FlatHub, and then I'll tell it the URL for it, which is https://flathub.org/repo/flathub.flatpak-repo. That file right there is going to tell it everything it needs to know about that repository. Now I can start searching for packages and installing them. If I do a sudo Flatpak search, I can search for an application like I use a little markdown editor called Obsidian. I'm going to reach out and see if I can find that one. So I'll just search to see. Not every application is in the repo, so you have to kind of decide. In this case, it is there, and in fact, there's a ton of different versions of it. It looks like themes and other things, but the main one I want is that very first one right there, that Obsidian stable. So if I just say sudo Flatpak install, and then the name of the package, or at least close to it. If I get close to it, I'll get a list and it'll let me pick. So it's saying it found some similar references on FlatHub. Oh, I forgot to tell it which repo to pull from. If you have more than one repo, it'll actually search from each one. And so it's saying, hey, I found something in FlatHub. Is that the one you want? I'll say yes to that. And now it's going to show me the different options. The main application is this guy right here. All these other ones look like themes, purple, gray, green. I don't need that. I just need the base application. So that's the 7th package that I found. It's going to identify it and then offer to install it. I'll say yes to that. and it's going to go in and start to do the install. Now, it is identifying some other dependencies and other things that come along with it. It's just saying, are you fine with this? Is this what you want to do? I'll just confirm that. And then there it goes, installing. Flatpak is more lightweight, so it actually has to do a little more work than what a Snap does. So Snap installs are pretty quick. They're already pre-compiled, batched, whatever. In this case, it's got to download separate archives, put them in the right place. But when it's done, I should be able to navigate into the Flatpak storage area, and see all the different files that are associated with it. So it is done, seems to be happy. It did not export a XML file, but that's okay. It'll get created when I launch the application. If I go into /var/lib/flatpak/app, that folder right there is where it installs, and I can see there's the Obsidian application, and if I look in there, there's the current, like what we saw with Snaps, and inside of it, I can start to find all the other information that goes along with it. You can have more than one version of an application installed, and so you'll see all of that kind of going along with it until I navigate in here deep enough to finally, eventually, find the binary buried down in here somewhere. Here we got obsidian.sh, which actually calls the application and brings it up. So it's buried away, installed, and available right there. So that's basically a Flatpak, very, very similar to what we saw with Snap.
All right, there you have it, ladies and gentlemen, supporting the Sandboxed application, some of the options you have available, such as Snap, Flatpak, and App Image, and how you can get them up and running in the different environments. That's all the time we have for this episode, but not all the time we have for the CompTIA Linux Plus series, so stay tuned.
Thank you for watching IT Pro TV.